would you agree that fear in parents often does equal damage, if not more, than what curriculum does a little less?
The number one cause of student anxiety in math was parents.
If your child is sitting there, staring at something, going quiet, taking their time, that's not failure. That's thinking, according to me.
So if they're using AI, let them use AI. But the problem is that we have not given a deterrent for them to use AI.
Right now, somewhere a child is sitting at a table, staring at a worksheet, believing they're bad at math. Not because they can't think, but because we've taught them that thinking takes too long. Hi, I'm Dr. Garima, and welcome to the Math Talks. This isn't a podcast about tips and tricks. It's not about helping your child score higher or get into the right program. This is about something bigger. What happens when an entire generation is trained to stop trusting their own thinking? Every episode, I speak with educators, researchers, and rebels who refuse to accept that this is just how school works. People who believe that math isn't the problem, our approach to it is. If you are a parent questioning whether the pressure is worth it, if you're a teacher who knows something's broken in the education system but are not quite sure what it is, if you suspect we are preparing children for a world that no longer exists, stay with me. Because the conversations we are having here, they're the ones most people are afraid to have out loud. Let's change that. So today's guest is someone who has spent nearly 2 decades in classrooms across continents, from Toronto to Switzerland, before walking away from traditional teaching entirely. Not because he stopped loving math, but because he couldn't bear what we were doing to it. Today, I'm joined by Sunil Singh, author, storyteller, and one of the most unapologetically honest voices disrupting math education today. Sunil taught math, physics, and English for 19 years, including at an international IB school. He's given keynotes around the world, led workshops at the Museum of Mathematics in New York and the Royal Conservatory of Music in Toronto. He's written 4 books, with the fifth coming in 2026, and co founded the Global Math Summit. But here's what makes him different. Sunil does not believe children fail math. He believes math fails children. The moment we reduce it to procedures, strip it of story, and teach compliance over curiosity. He doesn't talk about struggling learners. He talks about how we've built systems that train children to stop trusting their own thinking. And he does not offer quick fixes or curriculum hacks. Instead, he asks the question most of us are afraid to sit with. The problem is not that our children can't do math, but the math we've taught them isn't supposed to make sense. This conversation is not about better flashcards or finding the right tutor. It's about reclaiming what math actually is: a living language of patterns, stories, and human wonder. So, if you're a parent who feels a quite unease about what's happening in your child's classroom, if you watch them droop shoulders when homework time comes, or if you suspect that something essential is being lost in the name of rigor and results, then settle in. Because Sunil Singh is here to name what you've been feeling and to remind us all that math, at its heart, was never meant to be struggled with and survived. It was meant to be lived. Okay. So, Sunil, in my talks with parents across India and what I've heard from, educators across the world in my talks, everywhere math is like a big bully. Something almost every child is scared of. Not just children, parents even more. But what I feel is that math is actually not the beast. It is the way it has been taught across the world since ages, that it has lost its charm. From the time a child enters school, they're given sums to solve, worksheets to practice, but they're not given the skill to see math in real life, around them. So, from your work with Ola in Portugal and Rowan, I think in the US, two different children, two different systems, what convinces you that the real problem is not children's ability, but the way adults have designed the math curricula?
Well, first of all, thank you for that introduction. And I was listening attentively to every word. And there's one word I want to address right away because it kind of opens up the how I've been teaching with Ola in Portugal and Rowan in the United States. You mentioned about students having droopy shoulders if they get worksheets or if they do anything. So even if their students were, let's say, successful and scored top marks on their tests, examinations, but they did it while having droopy shoulders, or they had it while having a very uh, sort of tense body language, or whatever they're thinking, anxiety. That negates those marks because they learned mathematics under stress and duress.
True.
And it's just like when we eat, we should be relaxed because when we're not, our body stores the food as toxins. They've done studies on that. And since we're talking about food, because I want to get back to the question about Ola and Rowan about mathematics and the experience. Just yesterday, last night, I was talking to my friend Matt Whitehead. He's a musician, lives in the United States. He was about to land in Las Vegas, and we were talking about Indian food. He's a vegetarian, and he's not Indian, and he loves Indian food. And I was curious as to what was the first thing that Matt must have eaten for him to develop a love and curiosity for Indian food. Was it chana, chickpeas, bartha, eggplant? I don't know. But his curiosity to keep eating and discovering Indian cuisine came from a singular moment of introduction.
Absolutely.
And that same thing applies to mathematics. If we don't think about the introduction of this food, this buffet of mathematics, then we shouldn't be surprised that students don't like mathematics because we haven't thought about what they should be eating or how they should be eating. And so when I have been working with Rowan, who's 8, and Ola, 13, he has two different, Ola is homeschooled. Rowan is not. She goes to a school, but two different cultures, two different ages. But when you remove, there's two things. You remove the pressure of learning, but I also removed is the pressure on me to teach. I don't have a curriculum to follow. And just like when you would go to a buffet of, let's say, you know, uh, Indian food, Indian cuisine, you're not going to eat everything. You're not going to like everything. You're going to eat the things that you like, and you might eat more of that, and you might come back to something later. It's not a linear path. And so when I teach Ola and Rowan, um, what fuels all the learning is their curiosity. So if
Absolutely.
they ask me a question about mathematics or the topic, I will go with that flow. Everything is about flow, and through the interest of the child. And uh, when you remove those pressures, ironically or not ironically, they can learn so much more mathematics than we give them credit for. We think that young children, oh, they're just starting out, and we should be delicate with them. And no, as you probably know, once all those things are removed and the children's curiosity is at its peak when they're young, they're capable of doing so much.
Absolutely. I think I see that every time with my kids as well. So my son is 9 right now, and he knows a lot about, knowingly, unknowingly, he knows a lot about probability because that's, just around you. So that, and literally parents ask me, what curriculum do you follow? And I say no curriculum, because there cannot be any set curriculum that I can follow with them. It's just his way of learning, his curiosity, that it's just that we are engaged into maths.
Well, so you mentioned probability, and because even this whole podcast conversation is going to have its own flow. So probability um, really didn't take hold until the middle of the 1600s. A conversation between, I think, Fermat, and Pascal. And the mathematics of probability isn't challenging. Like, I mean, it's, multiplication, addition. And if you think about all the mathematics that have been discovered before that, like, pretty high level mathematics, why was probability such a late development in terms of our understanding of it? It was because of, um, at that time, especially in the West, religion and fate and determinism in terms of, so the whole idea that, no, there's no such thing as, uh, you can determine your own future. And so it was not allowed to even talk about probability and dice and things like that. So the math is easy. So, telling stories about the origin of topics has its own interesting human history around it. And again, going back, and we're going to go back to this a while, students and teachers, well, students especially, must see mathematics as a dead subject. It has no roots. It has no human uh, beginnings. It's like if aliens maybe dropped mathematics in a test tube on a beach 100 years ago. It's very sterile. It doesn't have, you know, uh, India's, of course, the history of mathematics is super rich. And I'm just curious, how much history do students learn about, Indian mathematicians in school?
Right. So I often say this, that school math is not difficult. It is disconnected. As we just discussing, it is disconnected from curiosity. It is disconnected from history. It is disconnected from real life. What do you
Yes.
think? Why has that happened, and why has it sustained for last 100 years? And still, I don't see much hope of getting it fixed in the current education system.
Well, you have to understand that mathematics education is relatively new, maybe 150 years, where mathematics is, over 5,000 years old.
Yes.
So we're kind of new in terms of math education. And then if you look at the purpose of education in general, is about scalability, proficiency, and all that. So we've taken the most boring parts of mathematics, and I mean most boring parts because it made me quit, um, and call that a curriculum. And the irony is that the things that we want our students to learn and do well at and be proficient with would have a better chance of happening if we were to really think about the curriculum. I'll give you a perfect example. This is a question I did with Rowan. Okay, Rowan is 8. Okay, and she's Indian, and she actually meditates too, which is important because she will spend more time on a problem, and having that patience for irresolution is so important. So here's a problem I gave Rowan just this past week. Okay, it's a very simple problem, but you can see hopefully that what she experienced is something anyone can experience and is more aligned to the kind of mathematics I do. So I told Rowan, do you know your doubling numbers? 2, 4, 8, 16, 32. Yeah, she knows them. And she also calls them binary numbers. So I wrote them on the side of the Canva whiteboard I was working with. And I only wrote them up to 32. We don't need to go past that. I go, Rowan, can you find two numbers that when you add them, any two numbers, that when you add them, they give you one of these doubling numbers. Okay. So, you know, uh, and she said 3 and -1. I was surprised she said -1. I wasn't expecting that, which was wonderful. And sure enough, 3 and -1 give you 2, which is a doubling number. And I said, okay, good. So when we have two numbers, we've maxed out. There's only one way to do it. It's kind of trivial. And then I told Rowan, okay, now we're going to have three numbers. Okay. So not two numbers, three numbers. So it makes a triangle. Okay. So if you look at each of the numbers as a vertice, so can you pick three numbers, Rowan, so that when I add them, all the three combinations, that they give me a doubling number? So she kept her 3 and -1, which was very clever. And then she had a 5. So if you add any of those numbers, 3 and -1, 3 and 5, 5 and -1, you get one of the doubling numbers. So
Right.
when there's three possibilities, Rowan got all three. Then we went to four. And with four, there's six possibilities because you have to look at the cross section, right? So after about a couple minutes, Rowan got four. She got 4 out of 6. Okay. And I go, Rowan, do you know that nobody in the entire planet has got more than 4 out of 6? So she was in shock that she had just accomplished something in which all of mathematics is stuck at. Nobody can find the four numbers so we can get like more than four possibilities of getting a doublet. Now, the truth is that the conjecture is you can't get more than four. We haven't proven it, but now I took Rowan from doing some basic mathematics, but adding the doubling numbers, some integers, and she felt right in the middle of contemporary mathematics. And that's the part we're also missing. Forget about the history of mathematics. We don't even teach kids what are unsolved problems like the one I did with Rowan. It's very accessible. It's the mathematics that they're doing already. But if you do it without context or story or interest or curiosity, why is anyone going to want to do it? Why is somebody going to want to add two integers, 3 and -1? Who cares? Right? So context, curiosity, and interest has to be there.
Right. And I think here in India, everything comes down to marks again. The exam is the end point, the goal, the entire justification. Because, you know, uh, but when I watch what's happening with AI, how fast it's moving, I feel this creeping panic as a parent. We are putting our children through years of stress. We are putting them through tuitions, weekend coaching. And for what, basically? Matlab basically we're just competing with machines that can already do it better. The jobs we're training them for they're also actually disappearing. The skills we're testing don't even transfer actually. And yet there is this pressure which is only increasing every time. So it's not just scary, it feels cruel at times. So the kids are also losing their childhood in India. They're first attending classes in school where they don't even learn anything, then they go to these unnecessary tuitions to make up for what they didn't learn in school. They might get marks but totally useless for career and future going ahead. And in that process, they end up hating learning anything new, which to me is the most important attitude you need in the future. The curiosity of learning new things.
Well, I'll tell you about AI. And I mean, we didn't think it was going to be a topic today, but you brought it up. I spoke about AI and math education in 2017. Uh, and I'm speaking about it again this June in Denver, Colorado, in the United States. This is what it comes down to. It's quite simple. AI is, again, a result of us, right? So nobody should be blaming AI. I mean, we created AI. AI didn't create AI. Okay, let's be clear. And if AI, and I think it was Arthur C. Clarke who made the movie 2001: Space Odyssey, who said this: if a teacher can be replaced by a computer or robot, I forget, they should be. And what he meant by that is if we are going to act like robots, then give the job to a robot. And because the only thing we have is our humanity. And the danger about, and I don't blame students using, large learning modules like ChatGPT or Claude. I don't blame them at all. They've been taught to game the system. It's all been about grades. So if they're using AI, let them use AI. But the problem is that we have not given a deterrent for them to use AI. We have not given them a good enough reason not to use it. And the good enough reason is if you give off your cognitive load, your thinking to a machine, you are now becoming more machine-like because you don't have an interest in being lost, confused. And these are very critical things in doing mathematics. Like there's nobody who's done mathematics in the history of mathematics, even the greatest mathematicians, who have not been lost, confused, bewildered, perplexed, have doubts. And if we are creating a mathematics system education, which is based on proficiency and how fast you can get an answer, we are robbing ourselves of the mathematical experience. But worse, we're losing our own identity, or to shape our identity when we're lost with a problem. We're not giving that time, that patience or resolution. We're not meditating on a problem anymore. And that's very
Right.
dangerous because as humans, we have this wonderful complex brain, and our brains are going to become machine brains like
That's
AI.
right. That's right. So, you recently shared an article on LinkedIn that really stayed with me, and
Good.
totally unsettled me in a good way, of course. So, you've taught to children from totally diverse backgrounds,
Yeah.
from one of Toronto's poorest neighborhoods
Yep.
to
Yep.
the International School of Lausanne, from coaching elite math teams in
Yep.
Europe, spending an entire day teaching math inside a juvenile detention center in San Jose. Working
Yep.
with mostly Latino boys aged 14
Yep.
to 18, I guess, right?
Yeah, it was. Yeah.
Many with gang affiliations.
Yeah, they were.
And after all of that, this is what you stated in that article, that your teacher degree gave you almost no real insight into how to actually teach mathematics, especially to such diverse learners. Could you please elaborate on that?
Well, yeah, I mean, I'm 61 now, gonna be 62 in May, and, through a combination of experiences you said, I feel finally I'm becoming a good teacher. And I'm not one of those people who goes, "Oh, I wish I went back and did that differently because I would have been a better teacher early on." This just shows you that the journey of becoming a good teacher is a lifetime,
Yes.
and a combination of all those experiences, teaching at an international baccalaureate school in Lausanne, where I took, elite math students to a math competition in Paris in 2006. And yes, I worked a whole day in a detention center with mostly, Latino boys who have a lot of gang affiliations. But guess what? The history of mathematics has transcended race, culture, class, uh, predicaments, everything. Whether it was Ramanujan on his deathbed, incarceration, a whole bunch of things. And that goes full circle to the mathematics that I'm interested in, the mathematics I teach, because that is the proven track record that has transcended uh, all different, race, civilization, cultures, all that, to have people have curiosity in mathematics and stay with mathematics. And I would say the biggest thing that I teach Rowan and Ola, um, and they already have it, but it's very important. And I punctuate this at the end of almost every lesson. I said, "Didn't we do things very slowly? Like we took our time. Like with Ola, she's 13. I just finished a calculus lesson on optimization. Now it sounds really like she's accelerated and all that. Calculus is really the idea of, instead of taking a slope between 2 points, the 2 points are almost on top of each other.
Yeah.
So it's not as wow, she's learning calculus. It's not that challenging, but if we taught it correctly with the right amount of time. But the what I was trying to say is I always underscore patience. That
Yes.
when we learn something, whether it's Rowan or Ola, that our last conversations are very light, um, and that because we can only do our best learning when we're relaxed and we're who
Yes.
we are. Like Ola is Ola. Like she's a like I is one lesson. I asked her, "How are you doing?" And she said, "Fine." I said, "Fine." That could mean anything. Give me a number from 1 to 10. How are you feeling? And she goes, "Okay, 4." I go, "Oh, she's feeling 4 to 10." And after we had a lesson, which I thought was a really good lesson, I go, "Ola, how are you feeling now?" And she goes, "Still 4." And I go, "You're still 4?" She goes, "Yeah, because I didn't sleep last night." So you have to have an honest relationship with your students
Right.
if they're going to learn, especially high level mathematics.
That's right. Okay, so you also said say that the people designing the math curriculum across the world are in love with, fancy, complex pedagogies, and they do not understand what it actually feels like to do a beautiful problem. You know, so that's very interesting. In fact,
Yeah.
what I've seen in India, I kind of agree with you about the curriculum part because I totally don't know why educators are in love with such complicated pedagogies and terminologies. But what I've seen from my own experience of teaching students from kindergarten to college students and teaching my own two kids is that if we observe them keenly and understand how they're actually learning, things are very simple. It's more about forming the connection as what you just stated and taking it from there. And what I've also seen is that when we get into all these complicated pedagogies, we end up pushing children unnecessarily, and they we don't realize it, but they end up hating math, and eventually they lose their interest in learning altogether.
Well, I'll say something that's not controversial, but I think students have a right to hate math, and I think they should have permission to hate math because that should be the feedback we should be getting as educators and teachers, or anybody who has a vested interest in mathematics, um, to be listening to them. But we still go on as though, oh, that's okay. I didn't like math too much. It's like almost medicinal, like you have to have it. And the pedagogy, I didn't even know what that word was when I first started teaching. I never heard of it. I might have heard it during my lessons during teachers college, but I didn't pay attention. I wasn't a very good student because I was bored by. Uh, they turned teaching into a science where, to me, teaching is really simple. Develop relationships with students, give them a good math problem, and get out of their way. And if you look at those three things, none of those things can be replicated by AI. Relationships, okay, AI can maybe find a good math problem, but get out of their way. AI is, if anything, doesn't want to get out of their way. They want to like give the whole answer and all that. Now, having said that, this is important. I think it's important that AI can actually be a beneficial tool here, or if it involves a student's curiosity. For example, I'll give you a perfect example of that. So I did this question in Austin, Texas, 2 summers ago to elementary teachers. I said, if you have a 2 and a 3, what's the largest number you can make with one operation? Okay. One operation only. Uh, so I said, okay, 2 plus 3 gives you 5. So I think we can make a number bigger than 5. I said 2 times 3 is 6. That's bigger than 5. Now, as I'm saying this, I could tell that some of the teachers are getting nervous because they had a feeling, even though they didn't know why, but the answer wasn't going to be 9. So eventually I got to 9. 3, the exponent 2 is 9. I said, this is not the largest number you can make with a 2 and a 3. And nobody knew uh, how to make it bigger. And we're not taught this. So this is where someone could look at AI and how do you make the biggest number with a 2 and a 3? They could look that up because they would be curious because they don't know the answer and they can't find it. They're not spending time. So a number that's bigger than 9 is if you wrote the 2 with exponent on the left-hand side, not the right-hand side. And that is the operation of tetration, which is an iteration of exponentiation. So that 3 on the left-hand side is telling the base 2 to make 3 copies of yourself as a tower of exponents. And you have to follow the exponent rules going down. So a tower of 3 twos, because that 3 on the left-hand side in the superscript has said, write 3 copies of 2. So the 3 has done its job. And now following the rules of exponents, 2 to the exponent 2 is 4, and 2 to the exponent 4 is 16. So I just made 16 with a 2 and a 3. Now you can make bigger numbers with other hyper operations, but the point was there's so much mathematics that people don't know. And not all the answers you may want to know, but I know that every teacher in that room want to know a number that's bigger than 9. And it was only because we was never part of the curriculum. That's why.
So this is hard to say, but it is necessary. In my experience, many children they don't lose curiosity at school first. They lose it at home, through anxiety, through comparison, through pushing unnecessarily and unreasonably, and also through, constant nagging instructions.
Mm.
Don't touch this, don't do that, do your homework, etc., etc. And this I'm saying totally out of compassion, out of my pain, because I feel that children can live without all this. Life can be really simple and even then more fruitful and peaceful. So, would you agree that fear in parents often does equal damage, if not more, than what curriculum does a little later?
Well, I know this because the New York Times had an article that came out maybe 10 years ago. It's pretty recent. New York Times, big newspaper publication in the United States. The number one cause of student anxiety in math was parents.
Parents. That's
And
true.
hang on, even good parents trying to help their students with the homework. So forget about the pressure and grades and this, you're not doing it right. Even good intentioned parents sitting down with their children doing the homework was causing anxiety. And look, that's like I've done math with my own kids, but the math that I do with my kids, first of all, has not been school math. It's been in places, and I did this on purpose. And this, for parents who are listening, this is really important. So I would do math with my children in places which they weren't expecting it. So if I took them out, let's say for ice cream, okay, and they're eating ice cream, it's a very a lot of kids, a lot of people love ice cream. It's a great childhood memory. I would ask them a math question while my kids, my daughter Rhea and my son Aiden, were eating ice cream, so that their memories of mathematics are always happy.
Yes.
They're because they're linked to other happy childhood memories. It's not sitting down at the kitchen table doing worksheets and things like that. I saw
Absolutely.
them do that, and they will tell you this too. Yeah, I mean, I used to try to help them with homework and stuff, and they would say this to me, especially Rhea. They call me Poppy. They said, "School is the dominant culture, and even though I know you're right in the way you teach and what you teach, everything you're saying, I go to school 6 hours a day. I have to play school. I have to do it their way. I have to learn it their way." And it really hit me as a parent and educator that all my good intentions were not going to land because I'm competing against school.
Absolutely.
I can't compete against school. And so luckily they have good memories when they were young of how much they loved math. I mean, uh, I knew they were both going to end up hating math, although my daughter has come around because she loves algebra, only because I taught her algebra. Algebra is easy. All your mistakes in algebra are arithmetic. Nobody
Yes.
makes it's rare to make an algebra mistake of choosing to, am I going to add, subtract, multiply, square root, take the log of both sides? That's your algebraic decision. How you tidy up after that is arithmetic. So a lot of students think, oh, I'm not good at algebra. No, you're not good at arithmetic. I'm not good at arithmetic. I'm very messy. And that's another thing too, is as a teacher, I tell Ola, I tell Rowan, and I've told all my students, like I tell them all my mistakes because it's very important to disarm your students to feel them like he's talking about his mistakes and like you're better like I tell Ola your arithmetic is better than mine. I tell Roland the same, like again, honest conversations, right? And without those honest conversations which center humanity, doesn't matter what mathematics you do, it's not going to stick. It's not going to uh, have a lasting impact just like anything else would. If you were forced into going back to my story, my friend Matt Whitehead, if he was say forced to have try Indian cuisine, oh, you have to try, no, you have to eat it now, right? Is he gonna like it? Probably not as much, but he was probably given freedom and he was around friends. I don't know but the environment was probably very friendly and curious. And those same environments that we use for trying new foods or new anything
Mm,
has to put in learning mathematics. And if it's not, we're gonna keep getting the results that we have been getting for over 100 years, which is anxious students.
absolutely. That I completely agree that mathematics is to be found around you, and you
Yeah.
can't just sit, with worksheets and questions to do it. I absolutely agree.
Well, and again, I have no problem with math homework. Again, I used to assign homework and I used to tell students, do as many questions as you think you need to do, because how can one student have to do 30 questions and like I used to do my questions backwards. So I would do the hardest questions first. And if I could do those, I wouldn't do any more. I was a very lazy math student. And only because I did enough for understanding. I wasn't gonna do those early questions, like, because I could probably make a mistake, but I the thing is I knew how to do them. You do enough questions until you know how to do it, and maybe a
Absolutely.
little bit more from muscle memory. I get that. And also, what kind of homework are you doing? Like, not all homework is interesting. And so sometimes, yeah, mathematics needs a little bit of, the push-ups or the exercises. You do need that, right? I'll give you a perfect example, a simple example of, because I know in India, like elsewhere in the world, we have to know our times tables, right? We have to know our times tables.
Yeah.
Okay. So 6 times 7 equals 42 is a math fact that it's a flashcard. It's a something that we have to know. Okay. Well, I can give you a better math fact than 6 times 7 equals 42. How about 2 times 3 times 7 equals 42? Because if you break numbers down into prime numbers, here's what you can do now. You can create a family of math facts for 42. So for example, 2 times 3 times 7 is 42. Take the 3, pull it out. You're left with 2 times 7. What's 2 times 7? 14. Put the 3 back in. You now know that 14 times 3 has to equal 42. So you create a family of math facts if you break down numbers into their prime factors. And knowing prime factors is something I've stressed with both Ola and Rowan. Rowan now knows her primes up to about 61. And the reason why it's important because if you know what your primes are, you also know what the numbers which are not prime. And having that relationship understanding, even know how numbers relate to each other, is the foundational part of learning arithmetic. And
Absolutely.
if your arithmetic is not good, everything else will collapse. So I'm a big proponent of doing arithmetic, but not the arithmetic they do in school. All the things I've done with Rowan and Ola have been number theory, right?
No.
Which is the actual
Yeah.
branch of mathematics, which has history and has a lot of things that people stress in a traditional curriculum, but I do it beyond. And if you do it in that context of math history as a branch of mathematics, which going back to that question I did with Rowan about the unsolved problem of squares of the binary numbers and adding, it goes back to that word. Their curiosity is maintained. And
Mm,
that's if I was to simplify it down to one word, and that's the same word for me, my goal at the end of every lesson, are they still curious about mathematics? A
absolutely. That's a
and through their
beautiful thought.
emojis that they send on the screen, and I can watch their face going back to where you made that first comment about the droopy shoulders. Their shoulders are never droopy. Okay, I watch their body language when they're doing the math, um, when they look up at the ceiling and they seem stuck, perplexed, confused, which I tell them are, if you experience these emotions, you're doing mathematics, right? You're doing
This is
mathematics. Like
a part
this
which
is
I've learned from you.
there's no
If you
shortcuts.
putting emotions, you're learning mathematics.
You're learning mathematics. Now, being
Yes.
confused and bored and anxious is not good. And uh, Rowan and Ola never exhibit any anxiety. They might have anxiety about, oh, is there an answer here? Is it like, am I being tricked here? They might be anxious about some of the trickery I might be up to. but it's never a unhealthy anxiety, which unfortunately um, math education provides.
Yes.
And they think they have solutions like, oh, how to overcome math anxiety. Why would you even say something? Like, why do you even have to overcome it? Why don't not even have it? Like they think that math anxiety is something that you inherit. Oh, we all had math anxiety. You can do it. No, that's the problem. Is that and math anxiety isn't the problem. Math anxiety is what comes later on. The first thing that happens with young students is alienation. They don't feel like this is something they want to participate in. They're not interested in mathematics. There's no anxiety yet. There hasn't been any high stakes testing. They're young, but they
Right.
feel isolated and alienated. And once the testing comes in, the anxiety happens. So before students got anxious, they got bored. They got bored first.
Yeah. So I feel the hardest work in education today is not learning new methods. It's, unlearning old methods and old beliefs. For example, it is so hard to bring in just one small change. Like in kindergarten in India, I feel, giving abstract sums like 2 plus 3 is absolutely wrong. And I've tried to get it right with so many teachers. They have to make just a small little change. So instead of 2 plus 3, asking, it should be 2 mangoes plus 3 mangoes, or 2 mangoes plus 3 pencils. You see, just by adding units to numbers, things start to become clear. 2 mangoes and 3 mangoes can be added, but 2 mangoes and 3 pencils cannot be added at all. So 2 plus 3 is not necessarily 5. In fact, it is 5 only in one condition, when the units or objects are same. In every other condition, 2 plus 3 is not 5. It is not 5 when you add 2 centimeters and 3 meters, and so many other examples as well. It is a very simple change, but very few are willing to change. And when I talk about beliefs, I mean, people in India have long believed that speed equals intelligence. The age old tradition of asking a child to narrate the tables, times tables, still stands strong, and judging their math skills on the proficiency of narrating tables. Another one which I see everywhere is good marks, which mean understanding the concept well, which to me is again not true. In fact, if I talk in mathematical terms, exactly the opposite is true. Good understanding is a necessary and sufficient condition for, getting good marks, but opposite may not be true. So, from your experience, what do parents need to unlearn first if they truly want to help their child?
Well, you mentioned about adding 2 plus 3. So, and my Hindi, I can understand Hindi fluently, but I can't speak it as well. But I do remember my ek, do, teen, char, panch. So this is a teacher I know, and she did this exercise at a presentation, and it was one of the most important presentations. She said, when students are learning mathematics, they're also learning language at the same time. So she told the audience that instead of the numbers 1, 2, 3, 4, 5, we're going to rename them red, car, blue, bird. Uh, I forget, but we're not going to name them 1, 2, 3, 4, 5. And now that we know that this is what they're called, blue is the number 2. She then asked us, okay, what's blue plus car? And I started to feel anxious because I forgot what blue was. Right? So she gave us real time anxiety about learning what we think is basic. But kids are also doing language acquisition. And they've also gone from concrete understanding of 2 to the abstract understanding of 2, the Arabic, Hindu Arabic numeral of 2. So it is so important early on that how students learn math. So, you mentioned numbers like that. So I don't know about in India, but in North America, they don't learn negative numbers till later on. Okay. I have a problem with that because uh, numbers are supposed to be on a spectrum, the integers, with 0 being the lowest number, you know. Brahmagupta. 620 AD, he wrote the book Brahmasputra Siddhanta. And -2 is not less than 0. The 2 conveys magnitude. That negative gives some sort of idea of maybe its direction or some weight. Like for
Yes.
example, an electron is -1, proton is +1. You would never say an electron is less than a proton. So this idea that zero not being the lowest number has been a problem in learning mathematics. But just going back to students and the different pedagogies, again, it's I would give kindergarten kids, uh, elementary kids, I'd give them this problem. We give them 2 subtract 1. Let's say 2 mangoes subtract 1 mango, and they say 1 mango, right? Okay. And they're very confident with that.
Yes.
I would do this. I'd go, what's 1 mango subtract 2 mangoes? Now, here's the thing. I would wait a week for that answer because I'm sure that children could come up with their own language of what
Yes.
that means. Yes, the number 1 will be there, but they don't have a mango. Do they have to give a mango to somebody? Do they owe them a mango? So the building of understanding of operations has to come from students' experience and knowledge. They have to feel like they're going to build the curriculum. Like we know what 1 subtract 2 is, but we go, okay, we have to decide, what does 1 subtract 2 mangoes mean? How about we discuss this in a week? Now, if you say that, that also gives them the idea that mathematics takes a while and that I'm given time to think about it. And then
Yes.
on a Friday, we meet. Who wants to share what 1 subtract 2? I bet you all the hands are going to go up,
Absolutely.
right? And that's what we're looking for. We're looking for that Friday class in which all the hands are up to a question which would not necessarily be in something they learn. That should be the goal.
That's absolutely right. In fact, I remember one of the instances when my daughter was just maybe 4 or 5, and I just randomly asked her that. So I had 12 toffees that time in my hand, and I just randomly asked that if I have to distribute these 12 toffees among four of us, how many each one of us would be having, without even understanding that she doesn't know division that time. And that was first hand experience of me teaching as a young child. And she just kept handing us the trophies, and eventually she came up with the solution that it is 3. I mean, she took an hour to do it, but then she did it, and I was happy for the fact that she's doing it. So I think they have to experience the whole thing, actually, instead of taking a pen and paper and writing it down. I think they have to experience the math around them.
And, you mentioned about the toffees. So here's a question which is somewhat related. So, you give students a question which there's 4 students. One student has 3 toffees, one has 4, one has 8, one has 9. Okay. So the kids can see that it's obviously not fair that, some kids got more. So they first the idea of equality. The question you give them is, okay, how about you redistribute the toffees and let's see how fair you can get. Okay. Now, what's going to happen is that they're going to redistribute them and everyone's going to get 6. So now you can talk about the word average, right?
Nice.
So again, these things I didn't necessarily think about when I taught high school. But when I say I'm a better teacher now than I ever was, it's only because I have more. I also I'll be honest, I do spend a lot of time learning math every day. So you say about teachers learning new pedagogy. Um, Again, pedagogy is not what they should be learning. They should be learning more content and more mathematics because that's where the curiosity comes from. That you can't expect your students to be curious if you yourself are not curious. So I have this book that's always on my desk. It's called the Mathematics Devotional and Celebrating the Wisdom and Beauty of Mathematics. Now, those are words we don't necessarily see. The idea, the word devotional or wisdom, but that's what mathematics is. And every day, if you open it up, There's a picture and there's a quote, something inspiring about mathematics. So it's always every day I read it for whatever day. Today is January the 29th. So I'll read January 29th. And I've read this for several years, but it's something I do daily um, to start my day, right? So
That's a nice
people might go,
memo.
oh, you're an expert and you've written all these books. I live in today, I live in the future. I don't live in the past. So what am I doing today to make myself a better human, to make myself a better teacher? In order to do that, I have to be a better learner. The best teachers that I've come across are fantastic learners. They are the best learners. That's what makes them the great teachers, that they are constantly learning. They don't stop and get on a podium. Oh, now I have the solution. No, I, I, I think I can even improve upon whatever I did with Rowan and Ola the previous weeks. But that's okay because that's human. And learning is messy, and mathematics is messy. And there's times where it's clean and elegant, but we have to show everything. And in school, going back full circle, mathematics seems very precise. It's based on proficiency. It's a very algorithmic way of learning. You're on
Absolutely.
a very narrow stairwell from elementary to when you graduate. Um, and it's all about, grades, performance. Who in their right mind is going to survive that? And children are our best indicators if we're doing something right. And if they're telling us through their anxiety, body language, uh, then we should be stopping and evaluating what we're doing and having different new pedagogies and things like that. And look, the way you teach mathematics, yes, I do with storytelling. So that is some pedagogy. But it's like if you came to a friend's house and they spent their entire time talking about their new kitchen. Oh, I have this wonderful oven now, and it cooks so well, and this new refrigerator. Look at all the different compartments. And for 1.5 hours, all they talked about was their appliances. At some point, you'd go, what's for dinner? What are we eating? I don't care about how my meal is going to be cooked.
True.
I'm concerned, what are we eating? And that should be for everything, when we have headphones on, you know, what are you listening to? What music are you listening to? What mathematics are you doing? If we're not critiquing the mathematics we're doing, then we deserve the negative output the students are giving us. Unfortunately, they don't have the capacity to know what they should be learning instead. They think this is the universe of mathematics. And that's even more dangerous because they have this confidence going, oh boy, I hated math. Yeah, me too. I hated math. And they start going around, but it's like if someone was to say, again, I've talked about food and Indian cuisine, so I might as well make it a theme. It's like if they're saying, oh, I had the worst Indian food one day. It was, I don't know what, I can't even think of something bad with Indian cuisine. And you go, that's not Indian cuisine. That's not, you didn't eat Indian food. And you think that's in like the same thing with math. People think, oh, and I tell my friends, like they're so confident, they go, oh, I was never good at math, or I was good at math. Even when they say I was good at math, yeah, you were good at school math.
That's not the
And
real math.
the reason why you like math is because you were good at it. There's nobody I know, very few people who like math who struggle with math,
Yes.
right? It's
Right.
correlated. Oh, I loved math. Why did you love it? Because you got good grades, right? That's why.
True. So, parents in India and even Indians who stay in US or UK feel that Indian education is so much better. They say there is rigor. Children are put under pressure from the very beginning and they learn to cope up well when they grow up. There are some who say that the elementary education is better in countries like Canada or Australia. as it is more relatable, more connection oriented than marks oriented.
Yeah.
But what I've seen is that children across countries show the same patterns: fear, dependency, loss of confidence when it comes to math. As per some latest data, the OECD PISA
Yeah.
2022
Yeah.
results show that average math performance across OECD countries fell by a record 15 points between 2018 and 2022. That was the largest drop ever recorded. And UNESCO's 2025 monitoring report finds that 6 in 10 children worldwide lack, the basic math skills by the end of primary school. So, in the US context, only again, there was another, statistics which I came across, that only 39% of fourth graders and 28% of eighth graders are proficient in mathematics according to national assessments. And, approximately 45% of high school seniors lack basic math skills. Uh, in India, it's a dire situation as well. As per some studies, 90% children at grade 7 level, they don't have basic math skills. So, from your global experience, what is universal about children and education, regardless of geography, which is, getting ignored?
So it's interesting you mentioned the 2022 PISA results because on that, on PISA tests, students can also answer questions about the attitude. Um, so up to 81%, now was Australia students. It went from 49, I think it was Ukraine, to a high of 81. 81% of Australian students who wrote the PISA test in 2022 admitted they didn't try. Now, this is the red flag. Like we wonder like, oh, the proficiency is going down and their ability, elementary, middle, high school, they're just not they're not functioning at that level for at least this one reason. They don't care anymore. They're tired of testing. They're trying to say that. So when someone fails a test, they go, "Oh my, they have all these gaps," and yeah, they probably do, but they also probably don't care. They don't care about the test anymore and what it shows, and also some of the ways that we teach are probably not the best, and some of the topics are definitely not the best. So universally, I can say this with some confidence. I know elementary teaching in North America is generally better. Generally better. I think there are some amazing elementary teachers. I could name a whole bunch. I think some schools are working in concert and doing great things. But I can say this with as much as you can get. I can say with 99% confidence because I know education all around the world. The math curriculum stinks worldwide. Okay. It's horrible worldwide. And people say, oh, IB. Yeah. They spent a couple months doing mock exams, practicing for IB. So again, the good news is that nobody's ahead. You could send your child to a private school, charter school, the best school. They may get other things out of that. And unless you're sending them to something like Exeter, United States, or the Proof School, San Francisco, and I'm sure there's a couple other places in the world. By and large, nobody's getting a good math education. Nobody. And when I say nobody, I don't mean nobody, but I use it in a very universal sense. And I can say that confidently, that unfortunately, we're still stuck in the way to teach mathematics, uh, how we value mathematics. There are no stories in math. The fact that I'm talking, you're in India and you're talking about Indian parents and Indian system, you have one of the richest countries of contribution to mathematics in terms of history. Do students know about Brahma Gupta in his book Brahma Buddha Siddhanta? Do they know about Ramanujan? Do they know about Bhaskara? Do they know about Indian mathematics, um, which basically by ninth century is really the foundation of a lot of curriculum, even in North America, in terms of trigonometry, quadratics. Where does mathematics come from? Do children know their own history? And there's a a great teacher, Professor Manjula Bhargava, who's Indian.
Right.
He teaches
Mm.
at Princeton. He won the Fields Medal, I believe,
Yeah.
in 2014. But one of the characteristics of people who love mathematics is that they hated school mathematics. He would not
Right.
even go to school. He would run away. So all these students were hating mathematics. I wonder how many Manjula Bhargavas are there. Like how many Manjula Bhargavas are in those students who go, I wish I wasn't in school today. I hate math. That to me is a point that we have never really dealt with seriously, I think, because the answer will come back to us adults that it's our fault, not the children's. That's I
Absolutely.
think that to me is why we kind of avoid that question in a deep way, because the blame will come to adults, not to students.
That's absolutely right. So I want to be very direct with parents for a moment. What is
Sure.
one thing you wish parents would stop doing immediately, even though they believe it's, kind of helping them? And what's one uncomfortable habit they need to sit with?
Well, I actually like I used to do this thing to my students. What should I stop doing? What should I start doing? And what should I continue to do? But to do with stop, um, I mean, we discussed it directly, indirectly. Stop putting pressure on students. Even if it's coming, and I know it's coming from a place of good heart, good intention. Okay, I know that it's you feel you're doing what's your best, but children are under so much pressure these days. Not just school, but just being growing up, being a young person, teenager, of just all the different things happening in the world, and the home is their home, and to have pressure come into that home, it's one thing for pressure to be at school, but the home should be a safe and comfortable place. So I would tell parents that you have to remove any pressure that you anything you may want to say, even if you think it's positive, like, um, "Oh, that was a good mark you got on that quiz." I know that sounds good, right? Um, and it's good, but the thing is, there might come a time where the mark is bad. So now there's expectation of these marks to be had. So don't have any communication that involves pressure. If you want to talk about mathematics that in a very contextual way that's maybe in the household, right? Making a recipe or something, you know, how many cups and things are in a very light way,
Light way.
but
Yes,
don't have any conversations about mathematics that can be traced back to inducing pressure. That's what
I
I would say.
agree. And I want to add something very honestly here. And I see this, with a lot, and, I'm saying this with a lot of empathy because I found myself doing it so many times. So most parents, they don't realize, but one of the most damaging habits, we've normalized it is pitching in for, your children very quickly. The moment a child hesitates, he's struggling with something, the moment they look uncomfortable, we try to fix it up for them, by explaining things, by correcting them immediately, by giving them the answer directly. And I understand why, again, that's coming out of love. Watching your child struggle is painful. You want to ease it, you want to protect them. But what we don't realize is that we're sending a message. We're saying discomfort means that something's wrong. Thinking too long is a problem. I don't actually believe you can handle this. This is something which the kids absorb. So here's
Right.
the thing we have to make peace with is that learning, as you said, that it looks messy before it looks clean. If your child is sitting there, staring at something, going quiet, taking their time, that's not failure. That's thinking, according to me.
That's thinking.
And what they need from you is that moment. In that moment is not help. They need your faith, your presence, not your intervention. To be comfortable in their silence, to allow them to struggle, to allow the child to finish their own thought. No,
Well,
that moment is
the struggle part is important. There's two things here I want to say. One, if parents, forget parents, if teachers knew the whole history of mathematics, it's been about slow failure. If you were to average all the outcomes of all the people, even the greatest mathematicians, and even just people who just took it in a very recreational sense. And you also have to understand that everyone who entered mathematics prior to formal education did so of their own volition and choosing. Nobody was forced, or very few, to learn mathematics. And yet, that's how amazing the subject was because everybody went into it transcending all races, cultures, civilizations, and indigenous tribes. They did it on their own because they wanted to. And they chose to struggle with things, ideas that were of interest. I think this is, we use this productive struggle and struggle in pedagogy, and I have a big problem with that. Why would I want to struggle with something that I find boring? Like, I'll struggle with stuff which I find interesting. Why are you punishing students and calling it, well, this is productive struggle? Like, there's I don't know if they have IKEA furniture in India. IKEA is that Swedish company where you buy the uh, at the store and you put your bed together or your desk together.
okay.
Um, I could do that. But I would not be a very happy person by the end because that's not stuff I like to do. That's not interesting to me. That's not where I want to put my hour, 2 hours of productive struggle. It's with things that interest me. And so when students productive struggle, what's the question they're struggling with? If I look at it, oh, yeah, that's a good one. I'm not giving you the answer. And if again parents knew that mathematics was slow failure, they would maybe back off from their children and let them experience that slow failure. But then we have to zoom in. What is the slow failure? It it will always go back to content. And we've talked about it, and I've mentioned a problem or two, but we haven't talked about it enough. That, people say mathematics. We're talking about mathematics. And a lot of my friends go, you must love mathematics. I go, well, that's about as silly as saying I love food. Do I love all food? No. We just can't say I get it, but there's part of mathematics which I just don't like. It's not my interest. I don't care. I don't want to teach it. I don't want to know anything more about it. And that's normal. It's human. I'm into math history, storytelling. I like number theory, graph theory, game theory, some geometry. Everyone's everyone's palette is unique. And again, going full circle back to Owen and Rolla, that's why it works, because we only do mathematics that interests them. That's it. That because the world of universe of mathematics, like how much mathematics do I know? Probably like 0.00001%. And so my understanding of mathematics is closer to that of Rowan's than to anything else. Like if I was on a spectrum. So the whole idea, oh, we're going to be able to learn. No, design a curriculum, whether it's personal or whatever, in which at least the first 3 years are guaranteed for students to develop a curiosity so they will learn mathematics on their own. Like, I'm hoping even now that one day Owen and uh, Rowan and Ola, they're not going to need me. They're going to be so curious on their own. That's my point. That's my end game. My end game is not for the learning to stop with me. Oh, well, that was great. I hope you had a great time with mathematics. I hope it's just the beginning. That's the mindset I have as an educator with them, and I've had for luckily for the longest time. Is I am just the beginning of their. If I look at I'm just the beginning of their math journey, then what do I introduce the beginning so they continue their journey lifetime?
Actually, we are making them absolutely opposite. We are making them more dependent on us. Yes.
Yes. Oh, and they and That's the kind of math. Again, people think the high scores and all that. Why do we have review in September when we come back to school? Like, why do we have review? Did they forget it? If they forgot it, they never learned it, because
Yeah.
learning by definition is holding on to something. So they didn't learn it for a number of reasons. One, because they didn't like it. So we're in this constant lie game that we play with students, that there's something happening here. And there's nothing happening here. We may look
Yeah.
at oh, I've seen the improvement in marks. Well, as someone who got a very high mark in calculus in my last year of high school, um, I was a fraud imposter. I just memorized how to do problems and I could recognize them. It took 10 years of me teaching calculus to finally go, okay, that's what's going on. Okay, so
Yes.
there's a lot of fraudulent behavior happening with grades and learning. It's at best transient, at best, because soon as that test is over, they forget everything.
Absolutely.
Yeah,
That's right. Okay, so one last question.
sure.
What I'm going to ask, I'm to now is that what every parent needs to hear and understand, and of course internalize. So today, if we removed worksheets, if we
Yeah.
remove tuition, fear, performance pressure, what would math actually look like? Would our children still be able to succeed?
Well, it's great if you were to remove all those things, and maybe as you're talking to parents, right? Um, one of the greatest things, you can do, of course, is to do things with your children, right? So I'm sure there are some households in which they cook together, right? They cook together. Someone's making chapati roti, someone's chopping whatever. Wouldn't you want that same experience when doing math? That
True.
how you feel about, oh, doesn't this meal taste better because we did it together? Not everything's going to translate one to one in terms of emotion and experience, but really that's what it should look like. That tell the parents should have a clear vision of, oh, I love it when my children cook or help out in the kitchen. It just more family time. Of course, we're eating together. Well, what would that look like? I'm not saying I have the answer, but wouldn't you want that same experience and story to
Experience.
tell when doing mathematics with them?
Absolutely.
Yeah.
Okay. So, thank you, Sunil, for saying what needed to be said, even when it's uncomfortable. So, to everyone listening, if this conversation unsettled you, if something here made you pause or question, or feel that quiet discomfort in your chest, don't push it away. That's not doubt, that's the beginning of seeing clearly. So, share this episode with another parent who's ready to question what we've been told is normal, with a teacher who senses something is wrong but does not yet have the words. Because our children don't need perfect systems, they don't need more techniques or better curriculum. They need us to be brave enough to stop pretending this is working. Thank you for listening, and until next time, stay curious, stay human, and please don't rush childhood. Thank you.
Thank you.